Okay, geometry, I am on page 597 here. We're going to look at example 4 and then a couple others after that. But example 4, they tell us in the instruction, it says AB, which is this line, right, this line segment, they say it is tangent, which means it's touching once, and B is the point of tangency. They also told us that AD is tangent, which means point D is the point of tangency up here. So we have two tangent lines. Now, if you look right above this problem in your book, you'll see Theorem 11.3. And basically what Theorem 11.3 says, if you have two tangent lines, like these two, if you have two tangent lines that intersect, that come to a meeting point, right, intersection right here, then they are equal. Okay, they are congruent. So we have a tangent line, we have a second tangent line, and they are intersecting, which means they are congruent. So congruent in math means equal, and equal means we're going to set these two things equal to each other. We're going to say 2x plus 3 equals 11. And we just solve it, right? If we're finding x, we solve. So we say minus 3, which gives me 2x equals 8. And you've probably guessed by now, x is going to equal 4. Okay? X is 4. Right? We just solve it by setting them equal. That's what Theorem 11.3 says. Okay. I want to look down now at the bottom of this page. You'll see the checkpoint. It's that thing in yellow. It's got problem 1 and problem 2 on it. You can see problem 1 here, problem 2 here. Do the same thing. They tell us in the instructions that these are tangent lines. And we can see how they're intersecting, right? So that means that they're congruent. So problem 1 doesn't even need to be solved. If this side is 15, if this tangent is 15, this tangent also is 15. All right? That one didn't need to be solved. We just look at it, and the top was 15, so x also must be 15. The bottom one's going to be, problem 2 is going to be more like the example 4. Right? They again told us this is tangent, this is tangent. Remember, tangent means it's just touching the circle once, here and here. Those are the points of tangency. And it looks like they're intersecting right there. So Theorem 11.3 tells us these two tangent lines are congruent. They are equal. So we will set them equal. I'll say 3x plus 15 equals 14. And now we just solve it, right? We're going to go ahead and subtract 15 on both sides, which gives us... I guess in the book, oh man, I got us going a little crazy here. The book, let's go back. The book actually, this is 3x plus 5. Sorry, I copied that down wrong. So I got 3x plus 5. All right, so we should say 3x plus 5 equals 14. Sorry, 3x plus 5 equals 14. All right, so we'll subtract 5 on both sides. Okay, remember they're still equal because they're still tangent. And that gives me 3x equals 14 minus 5 is 9. So we just divide by 3, and x will be 9 divided by 3 is 3. Right? This x right here is 3. Okay. That's all I have for you today. We have a very short video. Sorry for that error on problem 2. But remember that the Theorem 11.3 just says that both tangents that intersect are the same. Okay, are the same. They're the same length. So I want you to try a couple of problems here, you guys. Go ahead and go to page 598 for me. And I want you to do, let's see, I want you guys to try numbers 4, 6, and 11. Okay, you're going to do those ones on page 598. If you have any questions, go ahead and leave them in the comments. Otherwise, good luck.